For these questions, we're going to write the quotient and the remainder. The quotient is just the answer to a division problem, and the remainder is the number of leftovers that won't divide evenly. So let's look at some examples. On number 1, we have 32 divided by 6. We're going to look at a few different ways to model this before we actually say the answers. So for number 1, 32 divided by 6, we have two different types of models showing, and we're going to do a couple of other strategies as well. The first model uses little symbols to represent 32. If you count all of the stars, you'll see that there are 32 of them. So if you want to divide them by 6, you have to put those stars in groups of 6. So I'm just going to go start circling groups of 6. So there's one group, 2 groups, 3 groups, 4 groups, and 5 groups. But you'll notice that I have 5 groups, but I have 2 stars that aren't in a group. The extra ones become the remainder. So the answer for 32 divided by 6 is 5, remainder 2. And you write that as 5 and a little r for remainder, and then you write your 2. 5, remainder 2. There are other strategies you can use as well. You can use the number line and hop in groups of 6. So if you start at 0 and you do a hop of 6, you'll end up at 6. So you can have at least one group of 6. See how we made a group of 6 spaces? The next group of 6 spaces would land on the 12, and the next would be the 18. And we're going to keep going until we get to 32, which is where we want to end up. 32 is our ending line, since we're starting with 32 and dividing them. So I'm going to keep going in my groups until I get to 32. My next group of 6 would land on 24. My next group of 6 would land on 30. And if you'll see, I can't do another hop of 6. I can only do 2 more spaces before I get to 32. So if you see this, I was able to make 1, 2, 3, 4, 5 complete hops of 6, but then I have 2 little hops left, 2 individual. So we end up the same answer, 5, remainder 2. Both of these strategies are a lot of work because you have to have all these different stars or this number line. So there's another strategy that you can use. And you can use it by skip counting. So for dividing by 6, we're going to just skip count by 6. 6, 12, 18. Notice these are the multiples of 6. Okay, so I get to a point where my 32 is somewhere in between these two multiples. So the farthest multiple that I can go is the 30, which is the 1, 2, 3, 4, 5th one. So my quotient is going to be 5. I was able to do 5 groups of 6. I still wanted to go to 32 though, so I have to count from 30 to 32 by ones. So 30, 31, 32. So that is going to be 5 remainder 2. All of these strategies can help you find remainders. There's one more strategy that if you're really good at multiplication would be useful for you. What you do is, instead of thinking about division, you do the opposite of multiplication. You ask yourself, 6 times what equals 32? And this works just because of the fact families. So you know that nothing times 6 equals 32, but there's a couple of multiplication facts that get close to 32. There is 6 times 5, which is 30, and then there is 6 times 7, it's 42. There's 6 times 6, that's 36. All of these are close. So what you want to do is find the one that's closest without going over. So which one of these is closest to 32 without going over? Well, 6 times 6 is close, but it goes over. 6 times 7 is close, but it goes over as well. So 6 times 5 is 30. It's the closest we can get to 32 without going over 32. So our quotient is going to be 5. 5 is going to be our answer. And our remainder is going to be the number of digits between 30 and 32. So 30, 31, 32. So again, our answer would be 5, remainder 2. So all of these are different strategies that you can use to help find your answer. When you get really good at multiplication, this is going to be your best bet because it's going to be the most efficient, the quickest. So let's look at some other examples now. Okay, number 2 is 69 divided by 8. I'm going to use my last strategy, and I'm going to think about 8 times what is close to 69. So I know that 8 times 8 is 64. I know that 8 times 9 is 72, but right away I see 72 went over, so that's too much. So maybe I should try 8 times 7. That's 56. Well, 64 is closer to 69, so I know it's not going to be 8 times 7 either. So 8 times 8 is going to be the closest we can get. But it's not going to be exactly that, but we know that our quotient, our answer is going to be 8. So we know that it's going to be 8 would go here. That's going to be our answer. But 8 times 8 is really only 64, not 69. So we're going to have a remainder. We need to figure out that remainder by counting from 64 to 69. 64, 65, 66, 67, 68, 69. There's a difference of 5 between 64 and 69. So the answer is 8, remainder 5. Let's look at number 3 now. So for number 3, we have 7 times something equals 55. So we want to figure out 7 times what is closest to 55. So I know that 7 times 6 is 42. It's not that close. So let's try 7 times 7. That's 49. It's getting closer. 7 times 8 is 56. And I see right away that on 7 times 8, it went over. So it's not going to be that. 7 times 6 is not as close as 49. So our answer is going to be 7. But it's not going to be exactly 7 because 7 times 7 is really just 49. So the difference between 49 and 55 is going to be your remainder. So 49, 50, 51, 52, 53, 54, 55. So your remainder is going to be 6. So 55 divided by 7 is 7, remainder 6. So let's look at number 4. Here we have 19 divided by 5. So I'm going to ask myself 5 times what equals 19? Well, I know that 5 times 4 is 20, and that's too high. So it's not going to be 5 times 4. Let me try 5 times 3. So 5 times 3 is 15. So I know that my quotient is going to be 5 times 3, but the difference between 15 and 19 is 4, because 19 minus 15 is 4. So my answer is going to be 3, remainder 4. So now you try some on your own and use whatever strategy you need to help you get the right answer. If you need to rewatch the video, come on back. Good luck!